Now we're going to talk about variation. There are two types of variation in basic algebra. There's direct and there's inverse. Alright, so let's see, there's two kinds. There's direct variation and there's inverse variation. Now, when you're working with variation problems, it usually tell you with one of those two words. If not, you have to contextually determine which it is. Now, with direct variation, what this is there's like a relationship between x and y, okay? And with direct variation, if the quantity for y increases, so does the quantity for x. Or, if the quantity for y decreases, so does the quantity for x. With inverse variation, there's still a relationship. This is not the mathematical symbol to show that relationship. But anyway, there's a relationship between x and y, and if one quantity goes up, the other goes down. And it doesn't matter which one goes up, but if one goes up, the other goes down. So like, for example, direct variation example might be the more you study, the better your grades. Or the less you study, the worse your grades. Or the more you play on the PlayStation, the more your grades go down. Or the less you play on the PlayStation, the more your grades go up. So those would be two examples. The thing you start with every single time with variation is, if it's direct, you start with this formula, and if it's inverse, you start with this formula. Now what K is, K is my favorite mathematical oxymoron. K is called the constant of variation. Variation means change, constant means doesn't change. Altogether, what that really means is that this is how x and y are related. So while these things are going to change, this is how they change. So let me give you an example. Let's say that it'll say something like this: y varies directly with x, or as x, sometimes it says. And then it'll give you some relationship. So when y is 4, x is 1/2. Okay? So it'll first tell you how they vary, and then it'll give you like some description of the relationship. And then it'll say, maybe it'll say, find y when x is 6. Alright, well, the very first thing you do is you go ahead and you work with this. So we're going to start off y equals k times x. Now it says when y is 4, x is 1/2. We have to figure out what k is. So 8 is k. That's the first thing you got to do. This problem, I didn't tell you to do this specifically, but this is what you got to do first. This is perhaps the most important thing to find. Right here. It describes how they're related. 8 times of, sorry, that's supposed to say x. Y is equal to 8 times of x. So y is 8 times greater. Alright, well, so find y when x is 6. So 48. That's it. Or maybe it would say something like, find x when y is 12. I don't know. So we go back to using this again. So y is 12, and 8 times x, we got to solve for x. Divide. So let's see, that is 3/2. So 1 1/2 is x when y is 12. So that's it for direct variation. It works pretty easy. Now, what if we did the same exact problem, but it was inverse? So let's say it said y varies inversely with x. So this statement tells you how they're related, and this one's going to describe the relationship. When y is 4, x is 1/2. Alright. find y when x is 6. Alright, so first thing we do is start with this formula. We start with this formula because it says that it's inverse. Alright, now let's plug in our numbers. So 4 equals k divided by 1/2. Alright, I have to multiply both sides by 1/2. Right now I'm dividing by 1/2. The inverse of that is to multiply by 1/2. So 2 is k. So then my formula is 1/2 over x. Sorry, I was looking at the 1/2, so let me, y equals 2 over x. So this formula you have to get. You solve for k and you plug it into this thing right here. Okay, now find y when x is 6, so it's going to be 1/3. Y equals 2 divided by 6, so that's 1/3. Pretty simple, straightforward. All you gotta do is just, where students struggle with, what they struggle with is they don't start off with these formulas. They don't end up coming up with this relationship, this equation, and then because they don't do that, they can't plug the numbers in and solve for whatever it tells them to solve for. Okay, let's do the last one. I got one more. Let's say that y varies inversely with x. And let's say when y is 2, x is 5. Let's make it a little trickier. Let's say it varies inversely with, let's do this, the cube of x minus 1. Alright, so a little trickier. So let's say y varies inversely with the cube of x minus 1. Well, inversely means we're going to start with this. Right? First thing you do is identify if it's inverse or direct, and you write your generic formula. Second thing you do is you plug in your numbers. Now, this one says the cube of x minus 1, so we're really going to be using this. The cube of x minus 1 would be that. Now we can plug in our numbers. So when y is 2, x is 5. So we got to solve this for k so that we can write, like our formula is going to be over here. We're going to write y equals something over x minus 1 cubed. We have to figure out what that something is by solving this for k. So that's 4, which is cubed is 64. All right, so multiply both sides by 64, you get 128. So there's the formula we have to use. Now let's say it next asks us to find y when x equaled 2. Well, we just use this formula over here, so y equals 128 divided by 2 minus 1 cubed, right? 2 minus 1 is 1, 1 cubed is 1, 128 divided by 1 is 128, so there would be the answer. Now the trickier kind is, say y is 3. Find x when y is 3. So this is trickier. 3 equals 128 divided by x minus 1 cubed. Okay, it's just trickier because we have to do some inverse operations. First thing first, the thing we got to solve for, x, it's in the denominator, which makes this a little bit cumbersome. So what I would like to do is make this in the numerator. So I'm going to multiply both sides by x minus 1 cubed. Now some people say cross multiply, but there's really no such thing as cross multiplication. In fact, like, sorry for the tangent here, but people would say, well, if I wanted to solve that for y, I would just cross multiply. If that's all they knew, and the problem was like this, they'd be totally screwed. But if they knew inverse operations, it's really easy. So anyway, what I'm doing right here is I'm multiplying both sides by x minus 1 cubed. Alright, so that gives me 3 times x minus 1 cubed equals 128. I need to solve this for x. So I'm going to get rid of the 3 first. because this is in parentheses, and I have to take care of this 3 first. I cannot distribute because of that exponent. Divide both sides by 3. Let's see here. It's 3. It doesn't divide in. 3 does not divide into 128. So that kind of sucks. If it did, it'd be a lot easier. But here's what we got. X minus 1 cubed equals 128 over 3. We have to take the cube root of both sides now. So cube root, x minus 1 equals cube root of 128 over 3. I'm not going to worry about simplifying that cube root right there, because depending on the type of test you have, you might not be allowed to use a calculator. You might be able to, but that'd be for another story. Anyway, you're going to add 1 to both sides. So 1 plus the cube root of 128 over 3. Kind of an ugly problem because of this part, but the variation portion is really easy. Usually variation problems don't end up being quite this difficult algebraically. But anyway, variation. First thing you got to do in review, you have to determine if it's direct or inverse. If it's direct, you use this. If it's inverse, you use that. You plug in all the information you know so you can come up with the relationship. This one right here. And then you use that to answer the subsequent questions. Hope this helped.